Guys, so for the first thing we're going to talk about on this wonderful journey through e-learning is volume. So you've done volume before, I really would hope, grade school, middle school, somewhere along there. So let's just go back over real quick what our units are when we're talking about volume. So before spring break and before everything started happening, we did a lot of area. And we learned that the measurement for area is always that unit squared. So in this case, meters, so meters squared. Because what we were doing was we were measuring how many of these unit squares, or 1 by 1 squares, would go into a shape. And that's how we measure area. So the idea follows in the same way to volume. So volume is how many 1 by 1 cubes can fit into a 3D shape. So how many of those cubes could fit in a glass? Or how many of those cubes could fit in a box? Any shape. And that's why our unit here will be meters cubed. All right? So if we're going squared area, now that we're in the third dimension, so 3D shapes, our value or our unit is always going to be to the third power. So you should have a note sheet in front of you, whether you printed it off or it's just on your computer screen, and it's got about 4 example problems that we're going to work through. But before we do that, we kind of have to talk about how we find the volume of a prism in general. So if you look at this picture here, what a prism really is it starts as a 2D shape. So in this example, it starts as the solid red triangle. And then from there, what happens is it is stretched or pulled into the third dimension. So it goes from a 2D triangle on a piece of paper, and then we pull it. So it has 2 triangle faces, and then it has these 3, imagine, rectangular sides that connect this side of the triangle to this side of its shadow, this side of the triangle to this side of the shadow, this side of the triangle to this side of its shadow. So typically in prisms, we're always going to have some geometric face, whether it's a triangle, a rectangle, a square, a trapezoid, any shape you can think of. It will always have 2 of those faces, and then it will have these rectangular or parallelogram sides that connect the 2 faces. So when we want to talk about volume, we don't have just one equation because the faces can change. So in this case, each of our faces is a triangle, so we need to start with the area of a triangle. So the area of a triangle, if we remember, is 1/2 base times height. All right, so right now this guy is in, let's say, units squared. So now what we have to do is we have to give it the third dimension. Okay, so the third dimension in terms of a prism is always going to be what we refer to as the height of that prism. All right, so what the height is the height is simply the distance from geometric face to geometric face. So in the case of this triangle, height here. Now don't confuse the height in this case with the height of your triangle. The height of your triangle is still describing this distance here. Okay, so we have 2 independent heights. We have the height that talks about our face, so we would have the height of the triangle, and then we have the base of that triangle. So we start by finding that. All right, so let's give in some easy numbers. Let's say the height of our triangle is 2, our base is 2, and our height of our 3D shape is 6. So again, the first thing we want to do is we want to find the area of the face. You don't have to do both faces, just one face. So in this case, we have 1/2 of 2 times 2. So we know the area is 2, let's say we call it meters squared. All right, so now we have the solid red face covered. And really what we do when we multiply it by the height is we are stacking this triangle face on itself one after another to create that 3D shape. So this is a bunch of triangle of this size piece slices that are one after another creating this stack. So what that means is we're going to take our area and we are going to multiply it by, again, the height of the prism. So that tells us that if we have a 2 meter squared base and the height of that prism is 6, our total volume of that prism is going to be 12 meters cubed. All right? So in a nutshell, your formula for volume of a prism is always area of base times the height of the prism. So now what we're going to do is we are going to look at the 4 examples on here, talk about them a little bit, and just kind of go over the ins and outs of how we deal with these different prisms. All right, so in example 1 here, we have this rectangular prism, or as you're probably going to refer to it, it's just a box, okay? So all of its sides are rectangles, and it just so happens that the faces are squares. All right, now rectangular prisms are kind of the place where you can get away with not really knowing the bits and pieces. Because what's going to happen is, let's say we call this long face the face of our prism. Well, in that case, we have 4 times 12, so this face is 48, and then its height is 4. That works. All right, so in the case of a rectangular prism, our volume is simply length times width times height. All right, we need to know how broad the face of this shape is, how high it sits, how long it is. So in our case here, we have 4 times 4 times 12, all in this case being inches. So we can simplify that down to 16 inches squared times 12 inches. So that should be about 192 inches cubed. All right, the same thing's happening in number 2 here. Again, we have that rectangular prism, or that typical box shape. So we can use our, and how you decide what we call each one of these doesn't really matter. We have length, width, height, or length, width, height. Basically, you've got 3 values to describe 3 different things. You're probably okay here. So we're going to take 10 times 15 times 8. So if we simplify that, we have 80 times 15. So that should give us about, I think, 840. I guess we should double check that. And I was way off. So about 1,200 inches cubed. All right, for number 3 here, I've just drawn the face. Okay, I don't want you to get lost in the details, but what we have to figure out first is we want to find the area of the face. So right here, we have the height of this isosceles triangle, and we have the base. Okay, so we know our height is 3, our base is 8, so if we use our area of a triangle formula, we know that's going to be 1/2 base times height. So if we fill that in, we have 1/2 times 8 times 3. So we know 8 times 3 will give us 24. and half of 24 will give us 12 centimeters squared. And then if we look on our picture, we know that our length is 12. So we're going to multiply this by 12 centimeters, and 12 times 12, or 12 squared, will give us 144 centimeters cubed. And then for number 4 here, I've kind of done the same thing. Kind of just taking the third dimension out of it. We're just going to look at the face first. So if we look here, we've got our base, and we've got a height. So we'll use that same formula, 1/2 base times height. So that would mean the area of our face is going to be 12 divided by 2, so 6 meters squared. And then they tell us that the length of our prism is 10 meters. So that means the volume of our prism will be 60 meters cubed. Alright guys, that pretty much wraps up the notes for today. Your homework will be attached in the Google Classroom, and tomorrow we will go over the homework and talk about a few more problems, and we'll kind of go forward from there.